Well, today we're coming to one of the most important programs that is in Algebra 2 Unknowns. It has so much complexity, though I'm a little nervous about trying to do it all in one. It's over here at the left, function notation. Now we introduce function notation in Algebra 1. We increase our understanding of it in Algebra 2, and we really get a handle on it in pre-calculus. And then, of course, you have to be the master in calculus. So this first page of this program is just a gentle introduction to function notation. I remember that function notation was not used a lot in high school when I was a girl, and the f of x just threw me for a loop when I ran into it in calculus. If you look back in my notes, you'll see that everywhere there's an f of x, I wrote over it a y. It took a while before I got this notation. So this little f means that this function is dependent upon the x. There's no arithmetic on this x particularly. This says there's a function and it's dependent upon x, just like the y is dependent upon x when you have an equation. This is no different than the equation y equals 2x plus 7, except it's using function notation. Now, so a function is something that it generates values for the y. So I made this little machine here. We've got this function, and you can put any number you want. You could put a 3 in here and put it into the function machine, and it will spit out the value of the function. I'm going to have you do it by magic here, and then I'm going to tell you what it did. It took the 3 that I put up here and threw into the machine and said 2 times 3 is 6 plus 7 is 13, and spit out the value of the function. I could put in here 47, I think, and it would spit out that it was 101. Or I could say 1, and it would spit out a 9. Or if I could put in a 0, and it's going to spit out, easy, a 7. So this is for demonstration when you're trying to talk about what this function notation means. And then when you come to actually work the problems, you come over here and say new function. Now notice, now I have this function and it's asking for me to, oh no, this is giving me a new function so that I can play this game with it. And now press ready for problems when you're ready to practice. See, we could put something in this machine, 1, and it would be 1 squared is 1 times 4, 7, 11. Kick it out, and it's going to give me the 11. So I hope you see how this machine works. When I push ready for problems, I can't change the function, and now it's asking me to find f of 1. So f of 1, if I can do it in my head, I hope I can. 1 squared is 1, plus 2 is 3, and 4 is 7. So I'm going to put my guess over here, and when I check the answer, the program is going to put that 1 into this machine. See, I don't have the ability to put it in there now. When I go to check, it's going to do it and see if mine matches what the machine got. And so now I've got one correct prediction. So we can put f of 2 in here. Probably might need some pencil and paper, or I gave you some adding help here. So f of 2 for negative 4 plus 4 is 0, so it looks like this one's going to be 1. And I check my answer, and I hope I get it right. So this is pretty straightforward, just finding the value of a function at a particular value. You need to get really good at this. In Algebra 1, this is probably the first time you use this program, this is probably as far as you would get. But then you want to go to composition of functions, where things get a little more difficult. You ready? Make sure you work enough problems so that you encounter the composition of functions like f of g of x. So this one really will take a little more explanation. I hope that I come by chance to the kinds of problems we need. Now I give you 2 function machines. An f machine that grinds out the value of the f function, and a g machine that grinds out the value for the g function. And I give you 2 machines up here. And put a 4 in here, it spits that out. I put a 1 in here, it spits out the value of that function. You see that little sneaky thing? Watch for the red thing. It took me a long time to do it, so you better admire it. Watch it. So we can use these two machines, and so we're ready to begin questions, and it gives me these functions, and then it says find f of 2 plus 1. Well, it looks like they're not asking me a thing about g, so I have to ignore the g. F of 2 plus 1. So I put a 2 in here so I don't have to do that Mickey Mouse work that I did on page 1. Plug that in. Negative 2 plus 1 is negative 1. And I check my answer and I win. New question. Now it wants f of 4 times g of negative 1. F of 4, I'll plug that in, f of 4 times g of negative 1. Put negative 1 in here. I assume now that since you did page 1, you know how to plug things in and get the right answer. So now I need to multiply those. My goodness, I probably need a marker for that because I can't multiply that in my head. So I have to go negative 29 times 9 times 81. 1918. What's it? 26. 981. I think so. Negative. So it looks like it's negative 261. Negative 261. We check our answer. It says we're right. Now I'm hoping that we get, oh, here we got the one that says make sure you do enough till you get this. Now this one is where things get complicated and is the entire reason why I spent the several weeks writing this program. Find f of g of negative 1 or f of g of negative 1. These two notations mean the same thing. And I find this one easier to understand. You start with the inside and work your way out. So the first thing we have to find is the g of negative 1. So I'm going to put a negative 1 up here and find out what that is. Now then it says find the f of that answer. So now I'm going to put the 14 up here and find out my final result. It's minus 582. Check, we win. Hope you understood that. This is f of negative 4 times g of 2. 4 times f of 4. Just find f of 4 and then multiply it. This is f of negative 2 divided by g of 1. So f of negative 2 divided by g of 1. So this would be negative 4. You can put both negatives in here. I think you could put the, or negative 11, or you could put them both positive. Probably work good. It would be right either way. Sometimes enter numerator and denominator on these kinds of problems. Now, I hope if you can see this, you need to get good at this. You might have many, many questions. Now, unfortunately, with these, there's such a variety of the way things can be that teachers sometimes don't give students enough practice on homework for all the possibilities, and then they bump into something on a test for the first time, and it's not pretty. So you should probably, if you're studying composition of functions, you should probably spend quite a bit of time on this until it becomes just as easy as it can be. Now we have advanced problems. This is where we really need this for pre-calculus and calculus. Now this time, instead of putting a number in our machine, we're going to put letters in the machine. Now, I probably really have to have the marker for this. What if I said, what's f of x plus 1? This is sophisticated, not for the faint at heart. And it's going to come up with what the answer is, f of x plus 1, and it's going to work it all out. Let me show you how they got this. And because we haven't even gotten to the questions, we're still in the demonstration phase. So I'm going to bring the marker up here and we'll see. See, it's asking for f of x plus 1. F of x plus 1. And here it's the f function, so I'm going to use this f function. But everywhere there's an x, I need to replace that x with what it's asking me to find the value of the function. I need to replace it with an x plus 1. So f of x plus 1, hope that doesn't hurt your eyes too much. That's what you call complement, equal 2 times x plus 1 squared minus 1 times, if I can get the mouse to work, x plus 1. Look at what's happened here. I'm putting x plus 1 in is for here, and I'm putting it into this term, and I'm putting it into this term, and then we have to work this out. And hopefully you know how to square a binomial. Square the first, so it's 2 times, and when you square a binomial, square the first term, x squared. 2 times the first term times the second term, so that would be plus 2x. And square the last term, plus 1. Minus 1 times x plus 1, I'll just multiply that out now, minus x minus 1. And this would be 2x squared. There's my dog, I'm sorry. I was trying to keep her quiet, but it's hopeless. Plus 2 minus x minus 1. And so we have 2x squared, 3x, 2x, I'll come down here, 2x squared plus 3x plus 1. So 2, 3, 1. I'm going to have to minimize this. Hope I remember 2, 3, 1. And, oh, that's what it was. This was one of the sample problems, so you can see where they got that. When we do the question, see, this one I was able to put anything I wanted into there. But now when we come to do a question, it's not going to let me have this machine to do it. I'm going to have to do it myself. So you'd put x plus 1 everywhere there is an x. I'll do this one problem, and hopefully, God bless you, hopefully you'll see what we're doing. I dreaded showing this program, so now I hope you understand why. We're going to put an x plus 1 everywhere in that there's an x. So we're going to put in f of x plus 1 is equal to negative 4 times x plus 1 minus 4. So it looks like that's equal to minus 4x minus 4 minus 4. So it's minus 4x minus 8. And I'm going to minimize this, minus 4x minus 8. And check my answer, and it says I'm right. Now, sometimes the things get a little complicated here, and you might have to use all your Algebra 1 skills to do this. Function notation in the abstract. We need you to know this in pre-calculus and calculus. This program is something that you should come back to again and again until you get really familiar with function notation. Go back to function notation, simple function notation, composition of functions, and then advanced problems where we put in algebraic terms in for x. Hope you get it. Thanks.